Welcome to the second part of this topic, which is the exponential functions. In the last part, we spoke about the definition of the exponential function, and we said that the exponential function, it is a function of the form f of x equal to b to power x, where b is greater than 0, b is not equal to 1, and x is any real number. And we gave examples about some exponents and why do we need these conditions: b is greater than 0 and b is not equal to 1. And also we gave one example about how to graph an exponential function. Today we are going to take more examples about graphing or drawing the exponential function. Let's graph the function y equal to 1/2 to power x. Last time we graphed the function y equal to 2 to power x. This time I'm going to graph y equal to 1/2 to power x. And to graph this function, we choose points, select values for x, and find y. Usually 5 points will be enough for this one. So for x, we can choose any values, but usually we are taking positive, negative numbers. So it is -2, -1, 0, 1, and 2. Now x is my independent variable, but y is the dependent variable, which means that the value of y is depending on the value of x. So if x equal to -2, then y is equal to 1/2 to power x, which is -2. This is 2 to power 2, which is equal to 4. So y equal to 4. Now for the second one, if x equal to -1, this is 1/2 to power -1, which is equal to 2 to power 1. This is 2. So the second point is -4, -1 and 2. Third one, y equal to 1/2 to power 0, and this is equal to 1. Fourth point would be 1/2 to power 1 is 1/2, and last one will be 1/4. When x equal to 2, y will be 1/4. Now to graph this one, I have 5 points. So this is the y-axis and x-axis. First point was -2 and 4. If this is -1, -2, this is 1, 2, 3, and 4. This is 1, 2, and 3. This is 0. So -2 and 4 will be this point. Second point is -1 and 2. -1 and 2 is this point. Third point is 0 and 1, which is this one. And fifth one will be 1/2, 1 and 1/2, and 2 and 1/4. So we see that the graph of this function will be like this. So this is the graph of the function y equal to 1/2 to power x, or it is 2 to power, also we can write it as 2 to power -x. So it is 1/2 to power x or 2 to power -x. Last time we graphed the function y equal to 2 to power x, and 2 to power x was, okay, this is the intercept point. This function is y equal to 2 to power x. So 2 to power x and 2 to power minus x, they are symmetric around the y-axis. So we can say in general, this will be remark. Say 1, b to power x and b to power minus x. If we change the sign of the power, with the same basis, b to power x and b to power minus x will be symmetric. About the y-axis. Symmetric or reflections. I can say that the first function is like that we have a mirror on the y-axis. So the image will be reflected about the y-axis. So b to power x and b to power minus x are symmetric around or about the y-axis. Number 2, I mentioned this before and just going to repeat it. b to power x. If the base b is greater than 1, then the function is increasing. And if the base b is less than 1, then the function is decreasing. Now my function was 1/2 to power x. This is my original function. I just remove this one. b is equal to 1/2. So 1/2. So the function will be decreasing, going down. See, the direction of the figure is becoming smaller and smaller. So the function is decreasing. If the base is less than 1, then the function is decreasing. Number 3. I have f of x equal to b to power x plus sometimes something there. This is my c plus some constant in some cases. This constant will give me something called the horizontal asymptote. And the horizontal asymptote is the line that almost touch the graph. It is not intersecting the graph. For example, in this question, we can see this line, the y-axis, I'm sorry, x-axis, is almost touch. But it is not intersect. We can say this will be the limit of the graph. Well, it will not passing that line or intersect with that line. We call this is the horizontal asymptote. HA, horizontal asymptote. The horizontal asymptote in this case will be y equal to c. This number in the function. In my example, I have y equal to 1/2 to power x plus nothing there. So the horizontal asymptote in this case will be y equal to 0. Since we don't have anything, it means 0. I will call this as the horizontal asymptote. One more thing, sometimes we need to find this point when x equal to 0, the y-intercept, noted as what's it called? Number 4, y-intercept. This is if x equal to 0. If x equal to 0, y will be 1 in this function. So it is 0 and e to power 0 or 2 to power 0 or 1/2, depending on the base. It is b to power 0. So this is the idea of graphing an exponential function. Let's take one more example. Example number 2. Graph y equal 2 to power x. We graphed the function before 2 to power x, but in this example, I'm going to sketch the graph minus 2 to power x. I'm going to multiply the function by negative. Also, same thing. Let's choose 5 points for this one. X and y. 1, 2, 3, 4, 5 points. Minus 1, or let's say minus 2, minus 1, 0, 1, and 2. Now, if x equal to minus 2, then we will have y equal minus 2 to power minus 2. That will be minus 1 over 4. So this is negative, minus 1 over 4. If x equal to minus 1, second point, it is minus 2 to power minus 1, will give me minus 1 over 2. This is minus 1/2. If it is 0, will be minus 1. If it is 1, will be minus 2, and if it is 2, will be minus 4. So the graph for this function will be, first point is minus 2 and minus 1, 4. It is almost in this location. Second one will be minus 1 and minus 1/2. Third will be minus 1 down, 1 and minus 2. This is 2. This is 3 and 4 down. So it will be 1 and 2 and 2 and 4. So the graph for this one will be like this. So this is the function y equal minus 2 to power x. The reflection around the x-axis, we did it before. This is y equal to 2 to power x. It means that if we multiply the function by negative sign, we'll have reflection, but this time around the x-axis. So we can say now b to power x and minus b to power x are symmetric or reflection. About x-axis. So b to power x and minus b to power x. If we multiply the function by negative sign, then we have reflection around the x-axis. If we multiply the power by negative sign, we'll have reflection about the y-axis. Now, what else we have in this question? Y equal to minus 2 to power x plus something. Since it is not mentioned, means it is 0. So the horizontal asymptote is equal to horizontal asymptote is y equal to 0. It is this line. Number 3, y-intercept in this case, if x equal to 0, y will be minus 1. So it is 0 and minus 1. So 0 and minus 1. And the function is decreasing also, because we multiply negative, it was increasing, and multiplied negative, I will have decreasing function. So this is the idea of getting the exponential function.